Hi guys, this video is going to cover cofunctions for trigonometry as well as multi-step word problems in trig. Just a quick note from the last time, SOHCAHTOA will be used today to help us remember the trig functions that we're going to use: sine, cosine, tangent. The O, A, and H of course stand for opposite, adjacent, and hypotenuse. Sine and cosine are cofunctions of one another, where sine of theta equals cosine of 90 minus theta. Remember that theta is just an angle, some measure, like 60 degrees, 40 degrees, 23 degrees, it doesn't matter, it's just an angle. So here what we're saying is that the two expressions or numbers or values, whatever it happens to be, inside the sine and cosine functions should add to 90. And we're going to test that right here. We have theta plus 90 minus theta equal sign question mark 90. I'm telling you that they should add to 90. Okay, so now I am going to combine like terms. Theta minus theta, well, those cancel. So then I'm left with 90 equals 90. So this statement will always be true. Sine of an angle is equal to cosine of 90, take away that angle. So I've got this example written out here. It says sine of 42 equals cosine of 48. And again, you could test this. You could actually type both of those into your calculator. Sine of 42, enter. Cosine of 48, enter. And you would see that they give you the same value. But in this case, we could test it by seeing if they add to 90. 48 plus 42 is in fact 90. Now the next example is one where we actually have to solve. It says solve for x, sine of x plus 15 equals cosine of 2x. So again, take these two expressions and add them to 90. Combine like terms and solve just like you normally do. So I found that x is 25 when I solved that expression for x. And again, what you'll notice here is that we always have sine of a function equal to cosine of another function. When I say function, I mean expression or angle. Next, we're going to move into these multi-step problems, and I've got this example here so that you can see what I'm talking about by the fact that there's multi-steps or multiple steps. It says, standing on the gallery of a lighthouse, meaning the deck at the top of the lighthouse, a person spots a ship at an unknown angle of depression. So I'm just going to draw this. Depression means look out and then look down. And we don't know this angle of depression, so I'm going to choose to call it theta. The lighthouse is 28 meters tall and sits on a cliff that's 45 meters tall, as measured from sea level. The horizontal distance, that's left and right, between the lighthouse and the ship is 201 meters. Determine the angle of depression from the lighthouse to the boat to the nearest degree. So if the bottom from the base of the cliff to the boat is 201, then that means the top is also 201, because here we have a rectangle and opposite sides of a rectangle, of course, are congruent. Now, if the left side of this over here with the lighthouse and the cliff is made up of 28 and 45, our first step is to add them. 28 plus 45 to give us a total of 73. So then I'm going to label that over here on the left, but again, opposite sides of this rectangle are congruent. So if the left side's 73, so is the right side. Now step 2 is where we actually use our trig functions, where we circle the angle, label the sides OHA. Hypotenuse is your biggest side, O is opposite the angle, and A is adjacent or touching the angle. And now I'm going to think SOHCAHTOA. I don't care about the hypotenuse at all. I don't need it. So that means I'm using O and A. So tangent. Tangent of theta equals opposite 73 over adjacent 201. Remember, this is not a put over 1 and cross multiply problem. If we find angles, we have to use inverse. So theta equals tangent inverse of 73 over 201. This gets typed into the calculator. Also, you want to make sure that your calculator is in degree mode. So you're typing in tangent inverse of 73 over 201. And when you do that, you end up finding that theta is equal to 19.9602. And because the original problem said to round to the nearest degree, nearest degree means that I need a whole number. So taking this 19 rounding based off of the number after the decimal, so theta equals 20 degrees. All right, let's flip the paper and take a look at the next page. So we have some practice problems here. These first two came straight from Common Core exams. For the last three exams, June, August, and January, they have put a question on cofunctions on the test. So here in number 1, it says, which expression is always equivalent to sine of x? So I know if I have sine of some angle, it should be equal to cosine of 90 take away that angle, which means that if I just replace the theta with an x, I now have cosine of 90 minus x, choice B. Number 2 says, in scalene triangle ABC shown in the diagram below, the measure of angle C is 90 degrees. Which equation is always true? So I'm going to look at this real quick and see if I can eliminate anything. Remember that we're always supposed to have sine of something equal to cosine of 90 take away that something. Well, that means I can eliminate choice A and choice B. Sorry about the noise, my cat just sat on me. So again, eliminating choice A and B, because here I see sine equals sine, cosine equals cosine, which is not okay. Remember, we need sine of something equals cosine of something. Now we have to decide, do we want A and C or A and B? If C is 90 and we have three angles in a triangle, A plus B plus C equals 180. But we just said that C is 90. So I'm going to replace C with 90. But then if I solve by combining like terms, I now have A plus B equals 90. So that means that my two angles that are left over, angle A and angle B, sum to 90, which is perfect. That means that I need sine of angle A equals cosine of angle B, or vice versa. These can be flopped around because it doesn't matter which is which as long as they add to 90. So choice D. Number 3, we've got a flagpole at the top of a building, 300 feet from the base. The angle of elevation to the top of the pole is 32 degrees, and the angle of elevation to the bottom of the pole is 30 degrees. Determine to the nearest foot the length of the flagpole. So we're looking for this length up here. That's a vertical length, which means that I first need to find the entire vertical length, say x. Then after that, we're going to find the height or length of the building, say y. Once I have this whole piece of x, and I have this partial piece of y, in order to find the purple piece, I have to take x minus y to find the length of the flagpole. So here's a really big multi-step problem. First, find x. And we're going to actually redraw this picture. So we have a big triangle here, 300 as the base, x as my side on the right. and the angle of elevation to the top of the flagpole was 32 degrees. So we're going to work with this for a little bit, then we're going to find y, then we're going to find the length of the flagpole. So here I've got circle the angle, label the sides, OHA. Hopefully you found out that we're using tangent. Go ahead and try to set up that equation yourself. I'm going to do it here on the board, or on the screen, and you're going to try it on your own. So I have tangent of 32 equals x over 300. You can see that I put my tangent of 32 over the value of 1, so that this way we can cross multiply. X equals 300 times tangent of 32. We can type that right into the calculator and we get a value of 187.461. And at this point, I'm going to leave it as the big crazy decimal. I'm not going to round just yet. If we round too early, then our final answer would be wrong. So then step 2 is going to be to find y. And again, we're going to redraw the picture because sometimes it's helpful. Our right side is y, our base is 300, and this time we have an angle of elevation to the top of the building of 30 degrees. So same process, circle the angle, label the sides. And again, we're using tangent. This is still put over 1 and cross multiply. Make sure that you're checking in to see if you have the same exact answers. Y equals 300 times tangent of 30. So when we type that in the calculator, we get 173.205. So now I have an x value and I have a y value, and my last step, remember, was to find the flagpole. So that, again, was x minus y, or in other words, the big one minus the small one. So 187.461 minus the smaller value, 173.205. Go ahead and type that in. I found 14.256, and when we round, let's go back up to see how it says to round. Round to the nearest foot. So again, that's a whole number. Nearest foot. That means that we're at 14 feet. Final answer, the height of the flagpole is 14 feet. Go ahead and flip that paper over. Alright, so number 4 here is a Common Core question. It was on one of the 3 exams that they've released. It says, as shown in the diagram below, a ship is heading directly towards a lighthouse, whose beacon is 125 feet above the sea level. At first sighting, point A, the angle of elevation from the ship to the light, was 7 degrees. A short time later, at point D, the angle of elevation was 16 degrees. To the nearest foot, determine and state how far the ship traveled, from point A to point D. So we're trying to find this distance between point A and point D. Now, unlike the last problem, this one's a horizontal distance. So first, let's try to figure out point A to point C, say x. Then, let's try to figure out point D to point C, say y. And in the end, we need A to D, so again, take the big one, x, minus the small one, y. So same process as what we just saw, except this time, I don't know what the difference really is, except we're trying to find horizontal distances instead of vertical. So we're going to find x first. Secondly, we're going to find y. And then third, we're going to find AD. which we said is x minus y. So maybe you want to split your paper up just as I did, so that way you're not wasting space. Alright, so find x. Well, I'm just going to kind of try to resketch this quickly. We have x as our base, 125 as our height, and angle from point A is 7 degrees all the way up to point B. So circle, label, and guess what? We're using tangent. Tangent of the angle, 7, equals opposite, 125, over adjacent, x. Again, put it over 1, cross multiply and solve. This one's a little bit different when we cross multiply. We saw this in the last video, but we haven't seen it yet today. Here we have x times tangent of 7 equals 125. Now remember, our goal is to solve for x here. So in order to get rid of the tangent of 7 that's being multiplied, we must divide it. So on the left side, they cancel. That was the whole purpose. On the right side, that's what we type into our calculator. 125 divided by tangent of 7. When we type that in, we get 1018.04. So we're just going to keep it like that. We're not going to round. We're just going to leave it for now. Now for part 2, it says find y. So I'm going to sketch this picture again. My base this time is y. My height is 125, and my angle is now 16 degrees. So circle, label, and then start solving. So now this time again, tangent of angle 16 degrees equals opposite over adjacent, 125 over y. And then again, put tangent of 16 over 1 so that we can easily cross multiply. When we cross multiply, I have y times tangent of 16 equals 125. And again, to get y by itself, we have to undo multiplication, so that it calls for division by tangent of 16. Left side cancels, so now we have y equals 125 divided by tangent of 16 gives us 435.927. So now I take these values and I subtract them for part 3. 1018.04 minus 435.927. When we type that in the calculator, we get 582.113. And then it does say to round to the nearest foot, so that's another whole number. 582. Alright, last problem that we have here. This was not on a Common Core test, but I wouldn't be surprised if they tried to do something similar. It is getting you to think a little bit. It's multi-step, just like we've been seeing in the last couple problems. It says that Mr. Smith is standing between a tree and a building. His distance from each, as well as the angle of elevation to the top of the tree and the building respectively, is marked on the diagram below. To the nearest tenth of a foot, how much taller is the building than the tree? So if we have to figure out how much taller the building is than the tree, we probably need to find the height of the building and the height of the tree. So first, let's find the height of the tree. And we'll call that, say, x. Then secondly, let's find the building. And we'll call that y. And then thirdly, we have to find how much taller the building is than the tree. So we're going to go building minus tree, or in other words, y minus x. Okay, so we're focused on the tree to start, which means I'm going to circle the 32. That was a nice mark by my cat, Betsy. Okay, circle the 32, label your OHA, so the X is representing opposite, the 25 is representing adjacent, O and A again mean tangent. Tangent of our angle, 32, equals opposite X over adjacent 25. Go ahead and try to solve this. I'm going to pause the video and I'd like for you to do the same. When you hit play, you'll see my full work and answer for just X. Then we're going to move on to Y, starting it together, and I'm going to ask you to solve again. So at this point, you're pausing the video. You're going to solve this on your own. Okay, so I found X to be 15.6217. Now I'm going to move on to finding the building. So when I find the building, I'm going to focus on the other triangle, of course, and starting by circling the angle. Then labeling the sides, O for opposite, A for adjacent, H for hypotenuse. So the Y, the height of the building, is my O. The 72, the distance from the building, is my A. So again, in this case, we are using tangent again. So I'm going to ask that you pause the video at this point in time. You try to fill in this equation, and then end up solving it yourself. Hit play when you're ready to see the answer for Y. Okay, so I found Y to be 60.4152. And our last step, remember, is to take the height of the building and subtract the height of the tree to find out how much taller the building is than the tree. So now I have 60.4152 minus 15.6217. When I subtract them, we end up with 44.7935. And because it says rounded to the nearest tenth, my tenths place is the 7, so I look to the 9 to tell me how to round. Remember, 5 and above, give it a shove. 4 below, just let it go. So I'm rounding to 44.8. The building is 44.8 feet taller than the tree. And again, notice that this says picture is not drawn to scale. Sorry that the tree is ginormous in comparison to the building, but understand that the building is in fact taller. At this point, if you need to go back and rewind, pause the video at any point in time, feel free. Now you're moving on to your practice.